Welcome, this is Dr. Shiva Ayyadurai, and I want to really take a few moments to share with you some of my recent findings from my research on climate change. Many of you know that my background, some of the books back here that you can see has always been in science. I have 4 degrees from MIT. My PhD is in a field called systems biology from the MIT Department of Biological Engineering. And my other 3 degrees are in engineering and sciences. The reason I'm sharing that with you is we've gotten to a point in America in many ways that everyday people, not only everyday people, but particularly the youth in particular who are going to college, can tell a difference between, let's say, a baseball player, or let's say a major league pitcher and a little leaguer, or a great basketball player and let's say someone who's in high school. But for some reason, the educational system doesn't enable our people graduating colleges to really understand the difference between someone who has a PhD in, let's say, the sciences and someone who just has an opinion on something. C.P. Snow, if anyone hasn't read this great essay by him, I tweeted it out, called Two Cultures, said something fascinating. He was a novelist, a well-respected novelist, which means he was deeply involved in the humanities, but he was also a physical chemist. Physical chemistry is an amazing field of science. And C.P. Snow talks about in Two Cultures, in this essay, how he would go, this is about 60, 70 years ago, to some of the elite parties of his time in London, where, these were hoity-toity people, college educated, the elites, and he would ask them, how many of you know the second law of thermodynamics? And obviously these people would start looking down on him with disdain, really pissed off. But in his view, that question was, do you know the second law of thermodynamics, is no different than asking, do you know who Shakespeare is? He also made the question a little bit easier. Do you know the difference between force and mass and acceleration? And the same people would get quite upset with him, even on things like that. But in his view, that was the same as asking, do you know how to read? The reason I'm sharing this with you is not to put the humanities or sciences one above the other, but we have a whole tranche of people who are going to college, getting degrees in subjects which perhaps don't even require any significant skill, are highly subjective, and then those people are then up on Facebook, up on Twitter, and sometimes becoming talking heads on TV with absolutely no fundamental experience in science. And those people, in my view, are being used as the front end to a whole cadre of the elites who are using essentially, I hate to say it, but vulnerable, educated, quote unquote, idiots to promote different agendas. So let's talk about climate change in that context. I mean, some of you know I've been tweeting a lot about cannabis. Cannabis, there's 3 issues, before we get back to climate change, there's 3 issues really with cannabis. One issue with cannabis is the issue of, freedom and rights. Frankly, I don't want to impinge on anyone's rights. People can do whatever they want. The second issue is on legalization, decriminalization, prohibition, which is really a political issue. And the third issue is a scientific issue, which is, how does the cannabis of today work at the molecular level? How does it work biochemically? What have we discovered, and how do we put that together from a systems approach? That's the expertise that I have. I can have opinions on the other 2, but there are scientific facts and scientific realities. So many people out there, when I tweet out cannabis is a disruptor because it has high levels of THC for the endocannabinoid system, quickly react back. They'll write back reefer madness, or they'll start writing back stuff about, it's my right. That's not what I'm talking about. I'm talking about science. And that's what we need to get back to in America, because we have a whole set of people who are leveraging the fact in a very malicious way that many people do not understand science, do not understand force, do not understand basic chemistry, and they're taking advantage of people. So let's start with climate change. One of the things, by the way, when we talk about science, there's something called the scientific method. The scientific method is actually quite beautiful, but it's a finite set of principles which helps us discover truth from falsifications. And this is how it goes. You see something take place in nature, some phenomenon, apple falls to the ground, for example, and you as a human being who is curious about this decides to make a guess on why you think that phenomena is going on. So you observe something. So the scientific method starts typically with an observation of some phenomenon. And then there's the concept of an explanation. You want an explanation for that phenomenon, which is quote unquote a guess. And that guess needs to be validated through experiments, which means you take your guess why you think that's working, and then, which is called a model, by the way, the whys of why you think it's working. And then you actually execute a series of experiments in the real world to validate whether the experiment matches your explanation or your guess. If it doesn't match, then as Richard Feynman said, it doesn't matter how good looking you are, it doesn't matter what name you are, it doesn't matter what kind of person you are, your science is wrong. It's that simple. There's no political correctness, there's no opinion here, you're just wrong. And this is hard for people who've never had scientific training, who don't know how to solve math problems. By the way, a lot of everyday people who do plumbing, engineering, nursing, medical doctors, customer service people, engineers, we all actually understand this. We may not understand the math, but we know that we have to face reality every day. But there's a whole strata of people who have subjective ideas and they never have to face reality. And those are the people that are the most vulnerable to what's going on right now in the world. So, so what I want to talk about when it comes to climate change, there are theories emerging on how the climate changes. Now, me personally, and I believe most scientists would agree that the climate does change. It's always changing. CO2, which is carbon dioxide, is a greenhouse gas. Everyone will agree to that. Everyone will probably agree, most people agree to that greenhouse gases increase temperature. And people will also agree, including myself, that we as human beings emit greenhouse gases, okay? So those four things, if you wanted to make it a yes or no question, are obviously yes. But the people framing this question are framing it wrong. It's not a yes or no question. The issue is how much. That's really the question, how much? Because, you could say anything on the earth, a cow, pooping or farting has an effect on releasing CO2, and that can affect the increase in temperature. There are many, many things which can affect greenhouse gases. The issue is how much does that greenhouse gas actually affect what's called temperature change. So a little bit of science. You have the earth here and you have the sun here. Very simply put, the sun emits radiation. The sun is about 6,000 degrees Kelvin, or if you want to keep it in Celsius, about that plus or minus around 200 degrees, 273 degrees. But the sun is a radiating body, and it sends out visible light, which is what we see. And that light travels through space, and when it hits the earth, some of that radiation pierces into the surface and the oceans, and the other part reflects back. If you want to keep some broad numbers, the measure of radiation coming into the earth is known as flux, F-L-U-X, which is denoted as energy per an area, a surface area. So with the earth, it's with the sun, the energy that 6,000 degrees of temperature emits, the flux is 340 watts, which is a measure of energy per square meter, 340 watts per square meter. When that amount of energy comes to the earth, about 140 gets reflected back through various processes. It just gets reflected back into space. The remaining 200 watts per square meter, so 140 watts per square meter is reflected back. The other 200 watts per square meter makes it into the earth. And this is what creates what we know as a greenhouse effect. That's what warms the earth. Now, this is called the energy budget or the energy balance. You may hear this term. that 200 watts per meter, through a series of processes, also gets emitted back, so you have a net zero. How does that happen? Well, it's a very, very complex modeling process, a very complex system. Look, I do modeling for a living. As I mentioned, my PhD is in systems biology. In fact, I'm the creator of a technology called Cytosolve, which helps us model very complex biochemical reactions in the human cell or in biological functions. Well, I can tell you that models can be garbage in, garbage out. They're very complex systems of systems of systems. In the case of what we're talking about here with climate, there are really two very complex systems. One is the oceans and one is the atmosphere. Both of these systems are known as turbulent fluids. The atmosphere is a fluid of particles, which includes water vapor, greenhouse gases, but it's a very fast-moving fluid. And when I mean a turbulent fluid, think about if you boil water in the morning. That boiling of water is a turbulent fluid versus water just coming out of the faucet, which is much more predictive. The oceans are also another turbulent fluid, and they move at varying timescales. They're not as fast as the atmosphere. So you have two turbulent fluids interacting, and those two turbulent fluids interacting serve to emit or retain that 200 watts per meter that's coming into the lower atmosphere. So the question has been, how much do greenhouse gases affect the emission back of those 200 watts per meter? So when this entire argument or this discussion started, the modelers, there's actually 120 different models right now, and at some point we'll discuss how they do it, but their model said that if you have CO2, which is one of the various greenhouse gases, sulfur dioxide, etc., there's others, that if you double the amount of CO2, several hundreds of years ago, it was around 280 parts per million, and they said if you double it to 560 parts per million, that you will increase the watts per meter that the Earth will retain that won't be sent back by 3.7 watts per meter, and that would translate itself roughly into about 2 to 3 degrees centigrade. That's what their models predict. So the retention of additional heat would convert itself to a delta change or change in temperature from the global mean temperature. And they gave an error of that roughly from, right now the climate models say around 1.2 degrees all the way up to around 3.4. They have a range. And we'll discuss that. But their point is that CO2 is the thing that's driving that temperature up. Right now, according to measured data, it's around 0.8 degrees above the global mean as measured from 1850. Okay, so the average temperature of the Earth, if you look at that as of today, has gone up by 0.8 degrees. Their models predict it should be around 2.4 degrees. The important thing is that's what these models predict. But the reality is that if you actually look at the data and you look at what's going on, the prediction of the models and the actual measurements are not matching. The prediction of the models are much higher than what we're actually measuring. In response to that, the people who are doing these models will start doing hand waving and saying, oh, well, the measurement devices aren't correct, or they'll say, well, we didn't include other factors like aerosols. And so they always have made it very squishy. And this is where they're able to bamboozle people from a scientific method. Because a scientific method says, as I said, you come up with a observation, which they think that the Earth's temperature is increasing. And we'll talk about that. By the way, we had a little ice age a couple hundred years ago, and many scientists acknowledge that the Earth's temperature is increasing because of that. Anyway, we'll go up by probably 1 degree. But there's an observation that the temperature is apparently increasing. And then the the explanation is that it's CO2, right? So you see an observation, and these group of academics have said that it's CO2 that's causing it, and then they put together a big explanation called a model. Well, those models are not matching reality. And when they don't match reality, instead of acknowledging they don't match it, they make it even more squishier. It's the best word I can use. So you can never really get a handle and expose the fact that they're not following the scientific method, which is what they're not doing. Recently, so that's a CO2, and we'll discuss that even more. Recently, there's been some very interesting discussion, in fact, not discussion, but a research paper that came out of Denmark by a researcher called Svensmark, hopefully pronouncing it right, and it's fascinating. These group of scientists have literally worked about 20 years, and there's some videos out there, you could watch them on YouTube, but they came up with a theory. The theory they couldn't fully explain because the measurements sort of matched. They didn't. They went back another 4 to 10 years, did harder work, and now they have, they followed the scientific approach. They've actually done the hard work. And what they found is this. This is what's fascinating. They have, in my view, proven a input that was not considered before, that really shows how an external forcing can actually increase warming on the planet, which has nothing to do with CO2. So it turns out, as many of you know, if you believe in science and you're not a flat earther, the Earth actually rotates around the sun. Okay? The solar system is also very interesting. The solar system rotates around the Milky Way. If you look at the Milky Way actually has different arms to it. And those arms are filled with, all sorts of substances, but stars and radiation, etc. And in between those arms are space. So we, as a solar system, in addition to the Earth moving around the sun, the entire solar system is moving around the Milky Way, and it takes around 280 million years for the entire solar system to move around the Milky Way. Okay, so really simply put, we're moving around the sun is giving us energy, heat, but then we're also moving around the Milky Way. As we move around the Milky Way, the solar system are going through periods where in space, meaning we're not in one of those arms, and then we're moving into one of those arms. What they put together was another scientist, I believe in Israel or another part of the world, not in Denmark, had found some fascinating data, a very interesting oscillation pattern of data that coincided with the solar system moving between the space and then the arms, the space and the arms, which coincided with global mean temperatures on the Earth changing by 5 to 10 degrees, meaning that the Earth's temperature would go warm, very warm, during the periods where the solar system was going between those arms in the space, and then it was going down much cooler when it was going down into the arms. And this was observed independently, but they didn't know why. The scientists in Denmark had a theory, and that theory was that, and the theory actually derived from the fact that when the Earth moved through, or when the solar system moved through those arms, there was variations in cosmic radiation. So cosmic rays, for example, are put out when a supernova takes place, when a star is born or bursts, etc. Immense amount of radiation are put out. That radiation is a galactic factor. It has nothing to do with the sun per se, or something happening on Earth by us producing CO2, but this is happening in the formation of stars, etc. Cosmic rays come into the Earth. In fact, they're spread everywhere. And the level of cosmic rays, without getting too complicated, are low during that space, when the solar system is in that space between the arms of the Milky Way, and they increase when you go through the arms of the Milky Way because there's a lot more radiation, there's a lot more stars, a lot more matter. I mean, just think about space, and then you have a lot of stuff in those arms. So this is the data or the observation that they had, and the explanation was, could this explain or could this contribute to temperature increases on the Earth? It turns out that cosmic radiation, as it comes into our atmosphere, helps ionize, gives ions. Those ions create aerosols, which are essentially particles, air and solvents, water vapor, an aerosol particle, and they help those particles go from a small size to becoming larger size particles from 1 to 2 nanometers to 50 nanometers, but they actually help seed clouds. So to keep it simple, cosmic rays help form clouds. The more cosmic rays you have, the more cloud cover you have in the lower atmosphere. The less cosmic rays, you have less clouds. Okay, I'll repeat that again. More cosmic rays, ions help form aerosols, which help seed clouds. So that means when the solar system is moving through the arms of the galaxy, as we said, we have more cosmic rays, more clouds. When it's moving through the space areas, you have less cosmic rays, less clouds. So what do clouds do? Well, clouds serve to, when that 340 watts per meter comes, more of it is going to get reflected back. So you have less heating of the Earth. And what they were able to show was, and explain, mechanistically explain, this is important. One is correlation. CO2 goes up, you see something else go up or down. And by the way, it's not going up or down. The correlations aren't even matching in that case. But in this case, they were able to show the correlation of gamma rays, which mean cosmic rays hitting the Earth, and those forming clouds. So they've been able to show that in a very precise way. More cosmic rays, more clouds. And you can read their papers on that. The important thing that they found was that during the time cycle, during the galactic time cycle, the temperature of the Earth has changed between 5 to 10 degrees. In fact, having ice on the Arctic and polar caps is actually somewhat of a relatively rare phenomenon than when the Earth is actually much warmer, because it's moving much more through that space period, the solar system. So we actually have, when we're moving through that space, less cosmic rays, less clouds, more heating. In fact, we have very little ice. And when the solar system moves through the arms, we have more cosmic rays, more clouds, and we have a cooling. And that's why we have polar ice caps right now, because of that galactic cycle. Okay, so there's this one long cycle which takes over millions of years, that it itself oscillates, and that serves to explain these longer cycles of big ice ages and warming periods, big ice ages and warming periods. Now, in any one period, in a short time span of 1,000 years in geological time, you have, let's say, you're within the arm of the Milky Way, which is where we're right now. So we actually have a cooling. That's why we have ice caps growing. During that stage, as cosmic rays are hitting, there's another effect. The sun is also having, you could have a lazy sun, or you could have a very active sun. Active sun is, it's sending out more solar flares, more radiation. Now, it was thought that just the solar radiation hitting the Earth contributed very minimally to the heating of the Earth in terms of those changes. However, when you have high activity of the sun, that activity actually stops cosmic rays from, or lessens the amount of cosmic rays, which would mean what? Less cosmic rays, less aerosols, less clouds, and you warm. So whenever the sun is actually much more active, and it too has its cycles, various cycles, you will actually have a warming of the Earth. And what they calculated was that warming would be around, roughly around 2 watts per meter, which would contribute around close to 1 to 2 degrees increase. And unlike the CO2 correlation, which is not matching, the models are not working, so it's actually, frankly, it's failed science. This scientific work is showing in a very profound way that independent of CO2, that the Earth's temperature is warming, can warm and can cool because of cosmic radiation. So I wanted to share that with you because when you look at it from a very scientific standpoint, we have radiation coming into the Earth. Some of that radiation gets trapped and then later released. The amount that it's getting released or trapped determines the delta T, the change in temperature. This piece of work by Svensmark from Denmark has shown in a very powerful way, using real science, these guys worked on it for 20 years, that cosmic radiation, which means there are galactic effects. That means we live in a much bigger ecosystem versus us putting out little amount of CO2, which is claimed to drastically affect temperature change. That this could be part of a normal cycle, and their research says that we're going to have about a 2-degree warming, and this is part of a larger galactic cycle. So anyway, I wonder if anyone has any questions here. Someone said they're trying to match their model to theory. In fact, they went through various phases. They actually did match their model to theory quite well. In fact, they're doing further research in several other areas. Any other questions? That's it. All right. Well, I hope to do more of these series on a regular basis on taking a topic that's going on currently. It may be climate change, it may be cannabis. Sometimes I may go deeper into them. But my view is that I believe you are actually very interested in science. I believe you actually want to know stuff beyond simple sound bites. And that's what I hope to provide you. I believe it's important that we start having discussions that are deeper. We bring in math, we bring in science, and where there's gaps, we actually start training people. So keep an eye out for more of these discussions, and please tweet out to me if you'd like any more. I'm going to see if there's any other questions. Someone said, is solar system and SRM a space in between now of galaxy? I'm not sure what they mean. Oh, is the Earth warming still an issue regardless of the angle of the argument? That's a good question. So is the Earth warming an issue? This is a very good question. Look, let's acknowledge that independent of CO2, there could be many factors that cause all different types of temperature changes, that's why climate change is taking place. The real issue is, what can you and I do about if there's galactic issues taking place? Ultimately, it's going to come down to innovation. But what's really going on in this current situation is people are creating climate alarmism and subsuming everything else to this potential alarmism. And what's being subsumed is science, that you cannot debate this issue, so it's anti-science. Schumer has a bill in Congress, I believe it's Bill 792, to say federal agencies can no longer discuss climate change because there's a quote-unquote scientific consensus. So climate change is basically anti-science. Second thing is it's anti-green. Many of you know I've been a green environmentalist for years. I'm the main scientist in a movie called Poisoning Paradise, where we expose how the big agrobiotechs destroyed the native Hawaiians, their health and everything on the western part of Kauai, the Hawaiian Islands. The clean food certified standard, which is organic, high bioavailability, non-GMO. There's a label at Whole Foods. I'm the one who helped create that and facilitated that for the industry. I did a series of 6 papers exposing GMOs and how there's no GMO safety standards. So you're looking at someone who's actually quite green. I actually created email, which saves 1.8 million trees per day. But when it comes to climate change, in my view, it's actually anti-green, because we're not discussing air pollution. We're not discussing the fact that the Paris Accords, and listen to me carefully, allows China to pollute another 11 billion tons. Or as of 2017, they were at 11.7 billion metric tons of carbon. That's how much they've already polluted. They're allowed to pollute another 11 billion more tons. And when they pollute it's not just CO2. We're talking about lead and sulfur dioxide. These and other debris, particulate matter, cause all sorts of lung problems. The number one cause of death in the world is air pollution. So while we're here uncertain about CO2 and all this, frankly, nonsensical science, because it's not proven, we are not addressing the fact that Monsanto continues to pollute the world with pesticides. We have untested GMOs. We have the fact that there's plastics in the ocean. We have the fact that there's massive amounts of air pollution. China's allowed to pollute another 11 billion tons. That's what the Paris Accords allowed them to do. None of that is being discussed. Those are certain things. So as a scientist, as an engineer, and working people in this country want to discuss real things, because what they've done with climate alarmism is created an uncertainty. And based on that uncertainty, you and I are going to be taxed. The average working person makes $60,000. Today, 6.8% of his income goes to energy. With the situation that they want to do with this Green New Deal, the average working person will be paying about 16% for energy. It's literally a tax. So before I'm going to advise working people to get all alarmed about a model which is not even predicting what it says, I say we focus on what we do know if you want to be green, which is let's lower pollution, let's lower the use of pesticides, let's support local farmers, let's grow more trees. That's where we should be focused on, not this alarmism which essentially profits a few people. It's basically big climate. There's a lot of academics who are not scientists, by the way. Most of these academics who are in this climate non-scientific charade are essentially people getting lots and lots of grants. They're getting impact grants. The real scientists are not being allowed to speak, and that's anti-science, it's anti-green, and fundamentally this entire process is anti-worker because it's about imposing a tax based on supposed theories. Let's see if there's any other questions. I'm a big fan of yours, thank you. What else? Appreciate that. All right, so I hope this is valuable because I think we need to go back to science. And the reality is science is not easy. It's not an opinion. You go into the unknown. You don't know sometimes, so you have to go back and forth. You have to be skeptical. The academic is not skeptical. The academic is about selling. The academic is about getting grants. The academic is about getting tenure. A scientist is a revolutionary. A scientist is an everyday worker. And in this country today, the everyday worker and the everyday scientist has been essentially been attacked on and in some ways shat upon by wizards and elites. And in many ways, it's like going back to the feudal times where you had the serfs and the people who worked and the people were the enlightened scientists who were actually trying to figure stuff out. And over here you had sort of wizards and people were making up essentially snake oil people, and you have the elites. That's what's going on today. And unfortunately, in closing, as I said, we have a bunch of educated idiots, people who are getting college degrees, who do not know the second law of thermodynamics, who don't know biochemistry, who have all sorts of opinions. And frankly, they should go do their homework before they have opinions on things that have to do with whether you and I are going to pay more to support a whole echelon of people who are trying to make trillions of dollars off climate alarmism. Anyway, I hope this was valuable. This is Dr. Shiva Ayyadurai, and I'll keep you posted. Be well and good night.